Here's the weird part. A lot of AI does not understand words first. It turns them into coordinates.
Exactly. An embedding is a list of numbers that places something, like a word, sentence, image, or product, into a mathematical space where similar things end up near each other.
So the input stops being language and becomes a point on a map.
That is the useful mental model. Not a dictionary entry, not a symbolic rule tree, more like GPS coordinates for meaning.
Why should a programmer care? Because this sounds abstract until it hits production.
You should care, because embeddings power search, recommendations, clustering, deduping, retrieval for chatbots, and a lot of the systems that feel smart without actually reasoning much.
Give me one concrete example. No theory.
Say you run doc search for an API. A developer types, "How do I stop duplicate webhook events?" Your docs may never use that exact phrase. But if the query embedding lands near a page about idempotency keys and retry handling, you can still return the right answer.
So embeddings are how search stops being literal keyword matching.
Right. Keywords care about overlap. Embeddings care about closeness in meaning. That shift is huge, because users rarely ask questions using your exact vocabulary.
And that creates winners and losers. If your app finds intent, you look magical. If it misses it, users think your AI is dumb.
Yes, and the miss can be expensive. Bad retrieval means bad answers, weak support tools, irrelevant recommendations, and trust drops fast.
What actually goes into the numbers? Are we talking 10 numbers, 1,000, a million?
Usually, hundreds or thousands. Each dimension is not something clean like humor or price. The model learns the dimensions automatically, and together, they encode useful patterns.
That sounds like magic with a spreadsheet skin.
It feels that way, but the practical part is simple. Once items are vectors, you can compare them with distance or cosine similarity. Near means similar enough for your task.
Give me another scenario where this matters outside docs.
E-commerce. A shopper searches for office chair that won't wreck my back. Traditional search might chase the words office and chair. Embeddings can surface ergonomic chairs, lumbar support, posture, mesh backs, even if the product title never says wreck my back.
So embeddings help you capture intent, not just terms. That's a business advantage, not just a neat model trick.
Absolutely. Better matching means more conversions, faster support resolution, and less user frustration. The company with better semantic retrieval often looks smarter than the one with the bigger model.
Now the trap. What do beginners usually get wrong?
A common misunderstanding is thinking an embedding is a compressed copy of the original text that you can decode back into the exact sentence. It is not a zip file for meaning.
So you cannot take an embedding and ask, what sentence was this exactly?
Not reliably. It preserves patterns that are useful for comparison, not a perfect reversible record. Two different sentences can end up close because they mean similar things.
That also means close does not always mean correct.
Exactly. Similarity is not truth. If your data is messy, biased, or missing context, embeddings can confidently group things that should stay apart. You still need evaluation, thresholds, and domain testing.
Let me push on that. If embeddings are just proximity, where do they break?
They can struggle with very specific logic. Fresh facts, private knowledge they were not trained for, and domains where tiny wording differences matter, like legal clauses, medication instructions, or security policies.
So, the danger is using them like a brain when they are really more like a map.
That's the right framing. A map is powerful. It helps you find neighbors fast, but it does not replace judgment about where you should go.
And once you see that, a lot of AI products suddenly make more sense.
Exactly. An embedding is how software turns messy human meaning into something machines can compare at scale. Learn that, and you stop treating AI like magic and start using it like leverage.